Assalamu alaikum, welcome back to my channel Learn with Your Body, and today I am here with another video of our algorithm design and analysis series. And today we are going to learn merge sort. It is one of the most important sorting algorithms in algorithm design and analysis, and also merge sort follows the divide and conquer technique. Here the basic idea is divide, sort and then merge. At first, we will take our header files. This includes the IOStream library, which allows us to use the input-output functions such as cout and cin. And after that, we are using namespace std that allows us to simply write cout to display our output in the screen. And after that, we are taking our merge function. Now this creates a function named merge, and it has 4 parameters: array, the original array, and then left, starting index of the portion, and then mid, that means the middle index, and right, that's the ending index. And this function's job is to merge two already sorted portions of the array. And here void means this function does not return a value. And after that, we are calculating left half size. Here the integer in 1, this lines means this calculates how many elements are in the left half. Here we have also used +1, that's because both left and mid are included. Now suppose here left is 0 and mid is 2, so it indicates that 0, 1, 2, so that's 3 elements. So here n1 is equals to 2 minus 0 plus 1, so that means 3. Then we will calculate the right half size. For the next line, integer n2 equals to right minus mid. Now this calculates the number of elements in the right half. So here the right half starts at mid plus 1. For example, left equals to 0, mid is 2 and right is 6. So the right half is 3, 4, 5, 6. So n2 equals to 6 minus 2 equals to 4. Then we are creating temporary arrays. Now here we will create two temporary arrays, L for left half and R for right half. For example, like two numbers will be in the left half and two numbers will be at the right half. And then we are using a for loop. Now here we will copy the left half. So here it starts equals to 0, I equals to 0, and then it continues while I is less than n1, and after every iteration we will increase the I, that's why we used here I plus plus, which means I is equals to I plus 1. And then we are using L of I equals to array. Now this copies elements from the original array into the temporary left array. And after that we have used another for loop. Now here we will copy the right half. Now here this loop goes through the right half, and this starts with j equals to 0 and continues while j is less than n2. And right j, this copies elements from the right portion of the original array into R. And why we have used here mid plus 1 now, it's because the right half starts one position after mid. So let me just add the 1 there. Okay, it's fine. Alright, so now it's done. And then we will initialize 3 variables for integer I equals to 0, I, j and k. Now this is one of the most important lines. Here we are creating 3 variables like I equals to 0. Now this points to the current element of L, and j equals to 0. Now this points to the current element of R, and k is left. Now this points to the position in the original array where we will put the next smallest element. So think I is left, j is right, and k is the array. After that we're using while loops. Now here we will compare the elements. So this loop continues while I is less than n1 and j is less than n2, and here these both will be true. And in simple words, we will keep comparing elements while both temporary arrays still have elements. So after that we are writing if L left right. Now this compares the current elements of left and right, and then we are putting array plus k, that line. Now here we will put the left element into the original array, and these lines may look complicated, but it's actually doing 3 things. First, it will look the array for the k plus plus, and then it will do the I plus plus. So the smaller element is placed into the original array. And then we're using the else statement. Now if false, it will show us the R of j is less than L of I now. So we will take the element from the right array. And after that we are using void merge sort. Now this creates the main recursive merge sort function. So we know that here we are using array starting index and ending index. So its job is to divide and recursively sort, and then it will merge. And then we are writing if, and now here it's a base condition. Now this checks whether there is more than one element. Now if left is less than right, there are at least two elements, and if left is equals to right, there is only one element. Here a single element is already sorted, so recursion stops, and this is called the base. Then we have written integer mid equals to left. Now this calculates the middle index, and then we have merge sort array left mid. Now this is a recursive call. Now it tells the program apply merge sort to the left. Then we have written merge sort array mid. Here we will sort the right half. So this recursively sorts the right half, and again it keeps dividing until every part contains one element. Then we have used merge array left. Right now here we will merge the two halves. Once both halves are sorted, this calls our merge function. So they will sort left, and then they will sort right, and then they will merge them. This is the divide and conquer strategy. And then in our main function we will create an integer array containing 7 values, and here the index are 6, and we can see the values are given. And here we will find the array size. These are n equals to size of array from this. Now this calculates the number of elements in the array, and the size of array gives the total size of the array in bytes, and size of array 0, this gives the size of one element. So the number of elements equals to total array size or the size of one element. Therefore n equals to 7. And then we are using merge sort. Now here it will call the merge sort. Since n is equals to 7, so we have n minus 1 equals to 6. So this becomes merge sort array 0, and which means sorting the array from index 0 to index 6. And then we are using a print message. Now it will print the sorted array on the screen. And then we are using for loop. Now this will print every element. So this loop goes from I 0 and to I equals to 6, because n is equals to 7. And then we are using CR. This will print as the sorted array. So let's see it. Okay, so here is our sorted array. So we can say that merge sort uses the divide and conquer strategy. First, we repeatedly divide the array into smaller parts until we get single elements, and then we merge those elements back together in sorted order. The time of complexity of merge sort is O of n log n in the best, average and worst cases, while its additional space complexity is O of n. So guys, that was all about merge sort, and if you guys face any problem while from this video, please feel free to comment them in the comment section, and I will try to solve them. And also, if you guys find my videos useful, please like, share and subscribe my YouTube channel, and I'll see you guys in our next video. Till then, stay safe, take care, and Allah Hafiz.